Okay, so what we're going to do here is I'm just going to show you a few examples of how to identify whether a trigonometric identity is true or false. And I'm going to give you a bunch of these in the quiz, where all you have to do is select true or false, and you work it out and see if it's true or false. Okay. All right. So here's what you're going to do. In my opinion, really the real trick to dealing with trigonometric identities. So what we have here is cosine of theta times secant of theta is equal to -1. That may be true, it may not be true. If you don't have a strong understanding of trigonometry, if you haven't been working in it for a long time, you don't know right away. This could be true, maybe it's false. But here is my general rule is convert everything into sine and cosine. Okay, so secant can be turned into something that has a cosine in it. Tangent can be turned into something that has sine and cosine in it. And so if you convert everything into sine and cosine, you can work out your answer. Now numbers, you don't have to change numbers. You can leave the numbers as is. What I'm talking about here is trigonometric functions. So tangent, cotangent, secant, and cosecant. If you turn them into sine or cosine using one of the basic identities or some other identity, it'll be easier to deal with, okay? All right, so I'm going to leave cosine as cosine of theta, but I'm going to turn secant into 1 over cosine of theta, because we know that secant of theta is equal to 1 over cosine of theta, okay? And we'll put equals -1, right? Well, now let's do cosine of theta times 1 over cosine of theta. Well, cosine of theta, this is we can multiply this times a fraction. This is basically a numerator, right? It's like cosine of theta over 1. So we're going to do cosine of theta times 1. So it's going to go into the numerator. So we'll have cosine of theta over, and then 1 times cosine of theta is cosine of theta, right? Okay, equals -1. Well, what is cosine of theta divided by cosine of theta? Well, anything divided by itself equals 1, right? And so in this case, cosine of theta divided by cosine of theta is 1 equals -1. And this is not true. Not true, right? Because 1 does not equal -1. And therefore, on this one, we would select false. It is not true that cosine times secant is equal to -1. The truth is that cosine times secant is actually equal to 1. Okay, let's do another example. All right, so this one says true or false. We have negative tangent of negative theta is equal to sine of theta times secant of theta. Okay, so here's what I want to do. Before I turn this tangent, remember how I said turn everything into sine over cosine? Before I turn this into sine over cosine, I want to handle this negative theta. That's a negative angle, right? So I want to go to my negative angle formulas. And one of my negative angle formulas says that tangent of negative theta is equal to negative tangent of theta, right? Now I'm going to put that in parentheses here. See, I took this tangent of negative theta and turned it into negative tangent of theta. Okay, but I still need this negative. I got to carry that negative down. And so now I have negative tangent of theta, which is just tangent of theta. All right, good, equals, and I'll bring down sine of theta times secant of theta. Okay, now I'm going to turn everything into sine and cosine. Tangent becomes sine of theta over cosine of theta equals, sine is okay, it's just sine of theta, right? That doesn't have to be converted, but secant, isn't that equal to 1 over cosine of theta? And now over here I have sine of theta times 1 over cosine of theta. Anytime you're multiplying something by a fraction, this is always going to be multiplied by the numerator. So sine of theta times 1 becomes sine of theta in the numerator. And so on the right side here, I have sine of theta times 1 is sine of theta. And in the denominator, I have over cosine of theta. And sure enough, over here I have sine of theta over cosine of theta. And so now they are both equal. And so we can say that this identity must be true, okay? Let's do maybe one or two more. All right, this one says true or false. Sine of 2 theta is equal to 2 sine of theta times cosine of theta. We actually already know this is true. This is one of our double angle identities, right? So we're done, right? We're just going to put true and we're done. Well, actually, the reason I'm doing this is because I want to prove to you, I'm actually going to show you that this is equal to this, okay? And we can manipulate both sides, but I want to start with the left side here. Here's what I want to show you. Do you see this sine of 2 theta? A really neat way of dealing with sine of 2 theta is by turning it into sine of theta plus theta, right? Sine of theta plus theta, because theta plus theta is equal to 2 theta. But now that I've turned it into theta plus theta, I can now use one of my sum formulas, right? So if I have sine of theta plus theta, wouldn't that be equal to now to sine of A? So this is A and B, right? That's A and this is B. But they're both the same. So sine of A, which is theta, times cosine of B, which is also theta, plus sine of B, which is theta, times cosine of A, which is also theta. So look what we have here now. Over here, we have, I'm just copying from there over to here, sine of theta, cosine of theta, plus sine of theta, cosine of theta is equal to 2, carrying this down, 2 sine of theta, cosine of theta. Well, you bet that's true, because look, imagine that this is an x and this is also an x. Aren't both of these equal? Sine of theta, cosine of theta. Sine of theta, cosine of theta. There's one of these and one of these. And if we add them together, 1 plus 1 is 2. There are now 2 sine theta, cosine of thetas. And look what we have here, 2 sine of theta, cosine of theta. Therefore, this is definitely true. What I wanted to show you, the reason I did this example, and of course this is true, okay? But the reason I did it is to show you that these identities are all related to each other. They are internally consistent with one another. And I wanted to show you that you can break up a 2 theta into theta plus theta, okay? We're going to do one more that's kind of like this, and I think it's going to help you understand exactly how large the world can be with these identities. All right, so here we have one. This is just one of our cofunction identities. We know that sine of theta is equal to cosine of pi over 2 minus theta, right? Let's see, is this actually true? Sure, Mr. Ryan said it, he gave it to me, it's in my notes, it must be true, okay? Well, let's make sure that it's true using one of our other formulas here. We can use the difference formula, or the difference identity for cosine, and then leave sine alone over here. So we're going to say sine of theta is equal to, and then our difference identity for cosine, if you recall, is cosine, it's cosine. We're going to call, this is going to be A, the pi over 2, and this is going to be B, which is going to be the theta, okay? Now, it's not negative theta. That's simply the difference, okay? A is pi over 2, B is theta. So we're going to have cosine of A, which is pi over 2, times cosine of B, which in this case is theta, right? And now, remember, on the difference, it becomes a plus. So this becomes plus, and then it's sine of A, so sine of pi over 2 times sine of B, which is sine of theta, okay? All right, good. All right, well, so now what we're going to do, I'm just going to focus on the right-hand side here. We know that we want it to equal sine. Well, cosine, what's cosine of pi over 2? You look at the unit circle up at the top, cosine of pi over 2 is 0. So this is 0 times cosine of theta. Okay, cosine, now it doesn't matter what cosine of theta is. It's just cosine of theta. Plus, now what's sine of pi over 2? Well, sine of pi over 2, up at the top, we know that sine of pi over 2 is 1, okay, times sine of theta. All right? Now, what's 0 times cosine of theta? Now, it doesn't matter what the value of cosine of theta is. It's just, this is just a function, okay? It's not a value. But 0 times anything equals 0. So we got a 0 here, plus 1 times sine, well, 1 times anything equals that thing, and in this case it's sine of theta. 1 times sine of theta is sine of theta, and 0 plus sine of theta is equal to sine of theta, and therefore this is equal to sine of theta, and we can say that this is true, okay? So there are just several examples of how it is that we use trigonometric identities to prove that one thing is equal to another thing, okay? All right, that's it for trig identities, and just make sure you have them memorized and keep writing them down over and over and over again until they are all in your head, and you should be just fine.